tutorial on how to do a one sample t-test on SAS. So I know that you can, I taught you, or at least you saw the tutorials on how to code in SAS. Now with SAS University Edition, you don't have to code to do a lot on SAS. You can actually use the menu-driven system under what's called tasks. And it's really, really useful because you can do some really powerful things in SAS without having to code anything. Okay, so I'm going to teach you how to do the one sample t-test utilizing SAS University Edition and the tasks feature. Okay, so in general, with chapters 11 on, we're going to be doing analytic biostatistics. So that's basically trying to determine whether a hypothesis is true or not. Okay, so we're going to take typically, of course, a health-related or medical hypothesis and do some biostats on it to determine whether the hypothesis is correct or it's just due to chance. So that's what we're doing, right? So to do that, you need to know what the hypothesis is. So for each of these assignments and each of these questions, I want you to start thinking about what the hypothesis is. Now, a hypothesis is going to be structured so that an explanatory variable explains differences in the response variable. I repeat, an explanatory variable is going to explain differences in the response variable. Okay, so I want you to start thinking of what that explanatory variable is and what that response variable is. Okay, and then the next step is to determine what kind of variables the explanatory variable is, and what kind of variable the response variable is. And when I say what kind of variable, I mean, is it a categorical variable or a continuous variable? Okay, in these first few examples, up to about chapter 14, the response variable is always continuous, and the explanatory variable is categorical. All right, so the example I'm going to start on is on page 243 in chapter 11. Okay, this is the SIDS birth weight. We want to know whether birth weights of full-term infants who ultimately died of SIDS is significantly different from that of other full-term births. A sample of n equals 10 SIDS cases demonstrated the following birth weights, and it gives you some birth weights of 10 SIDS cases. Okay, and we want to determine if these SIDS cases had lower or different birth weights than full-term infants who did not die of SIDS. Okay, so based on this information, we calculate X bar and S. Okay, by comparison, the mean weight, okay, the X bar is 2890.5 and S equals 720.0. By comparison, the mean weight of other full-term births in the region during this period was 3,300. So we want to determine if that X bar that we calculated for this sample of 10, which is 2890.5, is different than other full-term births in the region, which is 3,300. Now it seems different, right? I mean, 2890 is definitely lower than 3,300. Seems like it's really much lower. But remember, we don't know if it's significantly lower. Could it just been due to chance? Okay, so that's what statistical tests will tell us. Was this due to chance, or what is the probability that this was due to chance? Okay, and that's the whole point of calculating p-value, right? So we're going to calculate a t-statistic, and from the t-statistic, we're going to calculate a p-value. Now you've done this by hand, and it's not that hard to do. And of course, you calculate the t-statistic. That's X bar minus mu over the standard error. Okay, and then you look up that t-value in the back of a book on a table and come up with a p-value. Okay, now it's kind of tedious. So, and this is best done with software. So we're going to do it on SAS. Okay, so the hypothesis here is that the null hypothesis is that mu equals 3,300. The alternative hypothesis is that mu does not equal 3,300. So that's essentially saying that the null hypothesis is that our SIDS cases, the mean value, the SIDS case, the mean of the SIDS, the birth weight of SIDS babies is no different than the birth weight of babies who did not die of SIDS. Okay, the alternative hypothesis is that the mean birth weight of SIDS babies is different than the mean birth weight of babies who did not die of SIDS. All right, so we need a p-value to determine this. So let's do this on SAS. Okay, the first thing you want to do always is look at the data set. So I'm going to go onto this menu here on the left side and look up under libraries. And then most of you will have it under biostats. Okay, I'm going to click that little arrow there, and you notice it's opened up. Now the data set, you don't have to enter this data. Okay, I already have it here. It's under the data set SIDS. So I'm just going to double click it. The first thing you should always do is look at the data. Okay, so this is the data set. It's a very simple one. There's 10 observations because remember n equals 10. So each of those represents one subject, one baby that died of SIDS. And then there's one variable, grams. Okay, you notice it's a continuous variable. All right, so it's a continuous variable, and it's the birth weights of the SIDS babies. All right, so simple data set, one continuous variable. All right, so next thing I'm going to do is I'm going to go up here back to my menu on the left under tasks and utilities. Okay, now I'm going to look under tasks, and notice I just click on that little triangle there, and then the lower menu opens up, and under statistics I'm going to find t-tests. I'm going to double click t-tests. Okay, now notice it already has biostats in it, but it might not. So the first thing you want to do is select a table. So you click on this little box next to the data menu here. I'm going to click on it, and notice, okay, actually you'll probably see this, okay, my libraries, and then I'm going to click on biostats, and I'm going to scroll down and find SIDS. Okay, there it is, okay, and I'm just going to double click it, okay, so you should do that. Under other roles, t-tests, you can notice that you have a choice of one sample, paired, and two sample t-tests. For this, I'm going to use one sample test. We'll learn how to do paired and two sample later. And finally, analysis variable, I'm going to click on this little plus here, and I'm going to indicate the variable that I want to do the analysis on, which is, there's only one variable, so it's easy, grams. All right. The next thing I want to do is up here, I'm going to go under options. Now I'm going to leave the two-tailed test alone, okay? One thing I have to change here is the alternative hypothesis. Now we wanted to, remember the null hypothesis is mu equals 3300. It's not 0, so I need to change that. I'm going to highlight that and I'm going to put in 3300. Okay, there, that's it. I'm going to leave everything else normal here. All right, I'm going to leave the plots at default. Test for normality. You don't have to click this. You don't have to do it. You can if you want. I'll just leave it there. We're going to ignore the results. All right. So to run it, I'm going to click on this little running guy. And then you're just going to do some stuff, and boom, here we go. Here are the results. Okay, so the first thing you want to do, okay, after you've determined what your hypothesis is, what test you're going to do, okay, and then look at the data, is I'm now going to look at what's called exploratory data analysis. And that's a complicated way of saying that I just want to look at the basic statistics, okay? So I want to look at the plot, okay? Whether that is a stem plot, okay? SAS doesn't do stem plots. We're going to do histograms instead. It's the same thing essentially. Box plots, so we're going to visually look at the data, okay? So you notice here's the histogram. It's kind of, it's kind of normal. The box plot, I think, is a better illustration here. And you notice that it is kind of normal. It might be skewed a little bit this way, okay? But pretty normal. And then I'm going to look at the exploratory data analysis. One of the things you have to learn about SAS is it's going to give you more information than you need. So the test for normality, we're going to ignore that, okay? We're not going to look at that. And there's also, notice at the bottom, there's these QQ plots. We're going to ignore that as well for now, all right? So the next thing I want to do, I looked at the data on the histogram and the box plots. I want to look at the basic statistics, the descriptive statistics. This is stuff that we covered in the first 10 chapters, okay? So here is the descriptive statistics that I want to look at. So here's the n, okay, 10, okay? We know this, there's 10 observations. The mean, the sample mean is 2890.5. Standard deviation is 719.8. The standard error, remember standard error is standard deviation divided by the square root of n, is 227.6. The minimum, maximum, and then notice down here I have the 95% confidence interval for the mean, which is also useful, right? So I want to look at those, okay? Always do the exploratory data analysis. You want to look at the data, right? Finally, here's the nitty-gritty. Here are the results. So the degrees of freedom is 9, which is, n minus 1. That makes sense. The t-value, so the t statistic is negative 1.8. Okay, if you did this by hand, that's what you would get, negative 1.8. And then here is the final result, the p-value. Okay, and SAS calculates that for you, which is nice. The p-value is 0.1056. Okay, so what does that mean? So it means that, remember, the p-value is over 0.05. Okay, therefore we do not reject a null hypothesis. I repeat, the p-value is greater than 0.05. Therefore, we do not reject a null hypothesis. Therefore, we conclude that there is no the SIDS babies, their birth weight is no different than non-SIDS babies. Okay, we cannot reject a null hypothesis, so we conclude that mu equals 3,300, meaning that the mean birth weight of SIDS babies is no different than the mean birth weight of non-SIDS babies. Okay, so the next thing you might want to do is print this out, print the results, and it's easy. You can come up here, so you see these little icons here. You can download the results in a PDF file. Okay, so this will be downloaded to PDF file. A lot of you will probably choose to do that. You can also download it into a Word file if you want to kind of annotate and add your conclusion. Or you can actually print the results. You put it you click on this little print icon, and it'll actually print the results. Okay. The other thing you can do is you can actually save this as well, so you can run it again. All right. So to do that, just click on this little floppy disk. I don't know why they still use floppy disks, because most students have never seen a floppy disk. But that's what it is. All right. So that's essentially how to do a one-sample t-test in SAS. All right. So it's pretty simple. And hopefully this will, now that you've done the t-test by hand once, you never have to do it by hand again. Okay. In fact, I prefer you to get used to using software to do this. All right.